What's up, ladies and gentlemen? Welcome to your next physics class. The topic continues to be impulse momentum theorem with, of course, me, your favorite teacher. So what are we going to do? We're going to continue to talk about the impulse momentum theorem, but we're going to see it applied to a deceleration. In our previous video, we saw the impulse momentum theorem applied to a collision. But here we're going to see what happens, how force, how time, how momentum and mass and velocity are related when an object, in this case, decelerates, when it stops. Okay, so what I'm going to do is I'm going to read an example that I have, then I'm going to explain how it works, and then what we're going to do is we're going to solve the problem. Now, real quick, I want to direct your attention to the formulas that we were working on last week, or in last class, where we said that force is the change in momentum over the change in time. Okay, but that change in momentum, as we all know, momentum is mass times velocity. So force equals change in momentum over change in time, but that change in momentum can be expressed as mass multiplied by the final velocity subtracted by mass multiplied by the initial velocity over the change in time, thus showing how time does affect force and does affect the momentum. So here's the problem. I went ahead and I did most of the problem so that way it's easier for me to break it down to you guys, especially because I don't have a calculator with me right now. And this way I can just kind of explain and break it down easier. But let's go to the story problem. The problem says, a 2,240 kilogram car traveling to the west slows down uniformly from 20 meters per second to 5 meters per second. We have two questions in this exercise. One is, how long does it take the car to decelerate if the force on the cars is 8,410 newtons to the east? And the second question is, how far does the car travel in the deceleration? So we want to know two things. How long does it take the car to decelerate, and then how far did it decelerate? So I was talking to some of the students in the virtual classroom today, and what I mentioned to them is that physics is a class that you really need to read the problems and pay close attention to the details. It's the details that sometimes get us, because sometimes they can throw us a curveball and give us extra information that we don't need, or kind of like sneak in some variable that you weren't really paying attention to. So let's find out what we've got. The problem gives us the mass of the car, which is 2,240. They give us the force, which is 8,410 to the east. Now, it's very important that you take into account the direction, because sometimes the force can be negative depending on where it's acting on. Secondly, the initial velocity, which is 20 meters per second, but it's to the west, meaning that the 20 is actually negative. And 5 meters per second to the west as well, which is the final velocity. And in the first question, they want us to find the change in time. So we're going to work with this formula, the impulse momentum theorem. Force equals mass multiplied by the final velocity minus mass multiplied by the initial velocity divided by time. Only in this case, time is what we're going to look for. So what did I do? Well, once I have my given, I just plug them into the formula. So force is 8,410. Mass is actually 2,240. The final velocity is -5 because it started at 20 and it slowed down to 5, and it's negative because it's moving westward. Minus the mass, which continues to be 2,240, multiplied by the initial velocity, which is 20 meters per second, but it was negative again because the car was moving to the west, over the change in time, which is what I'm going to look for. So what am I going to do? Well, and let me erase this real quick just so you guys know what I did, and then I can break it down to you one more time. What I did was I multiplied 2,240 times -5, and that's approximately -112,000, and minus 2,240 times -20, which is more or less -4,400 and -44,800, I'm sorry. So -112,000, which is what I got from this, minus -448,000, which is what I got here. So let me just go ahead and write it. So this is going to give me -112,000, and this is going to give me -44,800, okay? So that way, this is what happens. Okay, so once again, the product of this gives me negative 11,200, and the product of this gives me negative 44,800. So I'm going to subtract, which means I'm going to say negative 112,000. Sorry for that. Negative 112,000 minus negative 448. It's actually a subtraction problem, and that leaves me with 33,600. Now, over, of course, the change in time. What I need to do now is solve for the change in time. So I'm going to multiply by the change in time here. Okay? So this is going to cancel out. Okay? And then, of course, 8,410 times the change in time is 8,410. Change in time equals 33,600. So I divide by 8,410 on both sides. And this equals to 4. So let me write that a little better. So when I divide it, the change in time is 4 seconds, which means, guys, that it took the car 4 seconds to go from 20 meters per second to 5 meters per second. So once again, recapping real quick, I plugged in the numbers. I multiplied 22,400 times negative 5, which is my final velocity, and that gives me negative 112,000 minus 2,240 times negative 20, and that gives me negative 44,800, negative 112,000 minus negative 44,800. I actually add that, and negative plus a positive I subtract, and I get 33,600 over the change in time. I solve for the change in time. I multiply it on both sides. This cancels out. 8,410 multiplied by the change in time equals 8,410 change in time. I divide by 8,410 on both sides, and my time is 4 seconds. So I answered the first part of my question. But the second part of my question is asking me or saying to me, then how far does it travel? So I know it took 4 seconds to travel that velocity, but how long to slow down? But how long did it, or how far did it travel when it slowed down? So we need to use this formula. Now, in our previous chapters, we spoke about these formulas, which are the momentum formulas, or excuse me, not the momentum formulas, the displacement formulas, and they had distance and all these things. So we're going to reuse them. We're going to reuse specifically this formula that says that the change in x equals 1/2 of the initial velocity plus the final velocity multiplied by the change in time. So what I'm going to do is I'm going to plug in all the numbers into this formula, and then I'm going to find my answer. So we're simply going to say that change in x equals 1/2 of the initial velocity, which is negative 5, plus the final velocity, which is negative 20, multiplied by the change in time, which is 4. So I'm going to add what's inside of my parentheses, and that's going to be change in x equals 1/2 of negative 25 times 4, because negative 5 plus negative 20 is negative 25. Now, when you multiply a number by 1/2, it's the same thing as dividing it by 2, so negative 25 times 1/2 equals negative 12.5, multiplied by the time, which is 4, and the change in x is going to be negative 50 meters. Negative 50 meters, of course, to the west as well, because the car was moving westward. So you're going to say negative 50 meters or 50 meters to the west. Okay, so once again, what I did was I took my initial and final velocity. My initial velocity is negative 5. My final velocity is negative 20. Negative 5 plus negative 20 is negative 25. Negative 25, I divide by 2, which is negative 12.5, which I multiply by 4, and I get negative 50 meters to the west. And that's it, guys. That's the end of the example. So what I'm going to do is that along with this video, I'm also going to post 3 practice problems that you guys are going to work on. And remember to email me all of your assignments on Saturday. If you have any questions, feel free to text me. Guys, one last thing I want you to do. If any of these videos, the physics videos or any of the math videos that have been recorded previously, is helpful to someone that you think could use the extra help, go ahead and share the link with them. Ask them to subscribe to the channel, okay? Tell them to hit the bell notification, because this channel will be open to anyone who might need any help with math. So this is your favorite teacher signing off. Stay safe, and I'll see you at your graduation.